Yeah, good afternoon. I'd like to, on behalf of the Center for Water Technology and Policy at Hong Kong U, I'd like to welcome all of you to this interdisciplinary forum. My name is Frederick Lee. I'm the Executive Director of the Center for Water Technology and Policy. Yeah. As you can tell, the center is created to promote collaboration between the engineers and the social scientists. And that's the reason why it's named as Center for Water Technology and Policy. It's one of its, I think it's the first such center, okay, promoting interfaculty or interdisciplinary collaboration. Yeah. Now the center is new. The center was established here at Hong Kong U in May this year, so several months ago. And in May, we organized the first interdisciplinary forum. So this will be our second one. So the emphasis on interdisciplinary, okay, or interdisciplinarity, okay, is sort of like the trademark, okay, for the center. Yeah. Now, the center is devoted to becoming the focal point for water technology and water policy research. My colleagues and I, okay, believe in the importance of collaboration between the engineers and policy analysts. In the light of climate change uncertainties and also the changing configurations of the water economies in the greater peripheral delta region, we believe that it is very necessary for us to work together to redefine water resources management challenges for Hong Kong. Yeah, because there are unknown risks associated with climate change impact on our water sources in the peripheral delta region, and also there's changing configuration in terms of water supply and water demand in economies, okay, right next to Hong Kong, which we share the same water source, okay, the Dongjiang, the East River. Yeah. Now, I'd like to take this opportunity to introduce my colleagues on the center, serving on the center. We have two co-directors. One co-director from each of the two faculties working on the center. One is Professor Lee, X.Y. Lee from the Faculty of Engineering. Professor Lee, yeah. And we have another co-director from the Faculty of Social Sciences, Dr. Ng Cho Nao. Yeah. And on the staff, we have a research assistant professor, Dr. Joanne Yang, and a postdoctoral fellow, Dr. Angela Lee. So we have basically we have a 5-person team, okay, trying to build up the center into like a much stronger center, okay, in the coming years, okay. So we need your support. I'm very happy to see many old friends, okay, showing up today unexpectedly, okay, seeing some old friends in this auditorium. Yeah. Now, I'd like to introduce the two speakers for the day. Yeah. We are very happy to have two very distinguished speakers. One is Professor Varis. Please. And the second one is Professor Nickum. Yeah. I'll start with Professor Nickum. Professor Nickum is a water economist working on water resources management since the 1970s. He first went to China in 1974, okay, so he has decades of experience, okay, looking at water resources management in China and also other parts of the world, okay. So he has served as the Vice President of the International Water Resources Association, and currently he is the Editor-in-Chief for Water International, and he's been in that position since 2007. And he's also a professorial research associate with the School of Oriental African Studies, University of London. And he is now, we have invited him and also Professor Varis to serve as our international advisors for the center. Yeah, so Professor Nickum. And Professor Varis is a professor of water resources management at Aalto University. And he has served, he has been very active, okay, in several international organizations, including UNESCO, HMO, and also the International Water Resources Association. Similar to Professor Nickum, he has also served as the Vice President of IWRA. And he is now currently and also earlier served as the Vice Dean for research and innovation, okay, at the School of Engineering, Aalto University, and he's also, at the moment, a distinguished adjunct professor at AIT, Thailand. So we are very happy to have two very distinguished speakers with us today to share their thoughts, okay, on water technology and water policy that may have direct and indirect relevance, okay, for Hong Kong. Yeah. So we are going to have a group photo.
I feel a little awkward actually calling Professor Lee because we've been old friends and colleagues since, about 30 years. And we used to work together in an interdisciplinary program called the Environment and Policy Institute at the East-West Center, where we got our sort of feet wet in working on interdisciplinary work with a policy focus. So I'm really excited to be invited to be a part of this new center's activities. And what I would like to do is, and I'd also like to thank everyone here, it's quite an audience, for coming in from a really tremendously beautiful day out there to hear us talk. As mentioned, I'm the editor-in-chief of the journal Water International of the International Water Resources Association. This is what it looks like in hard copy, which is rather rare these days since, of course, everybody reads things online. But I also am involved with a lot of the research activities of IWRE outside of Water International. One of those is that we just did recently is this 500-page report on smart water management case studies that was done together with the Korean water agency, K-Water. And that's where I'm going to start in my description today. So, without further ado, let me move on. Rough outline of the presentation. Presentation kept changing every time I went back and worked on it, but right now it's what is smart water management? Let's get that started. And an overview of some of the cases that we looked at that, at least with my knowledge, would be of possible interest to Hong Kong. I don't know Hong Kong's situation in great depth. I was involved in some with Hong Kong a couple of years ago in looking at some studies with Professor Lee, and some speculation on the applicability or inapplicability of those case studies. Looking at limitations of smart water management, at least in terms of the case studies that we looked at, but proceeding from there to looking at promising areas for development, both for Hong Kong and for the research possibly of the center. Now, what is smart water management? There are a lot of different definitions of it, as is common with new fields and terms, but they all center around the idea of information and communication technology, new technologies, the kinds of technologies that will provide real-time information that can be automated, often are merged together with artificial intelligence kinds of waves, and depending on the definition, who's defining it, the K-Water didn't include it so much, but it often is also used for integration. And I think that's actually integrating what was formerly not integrated or capable of being integrated is one of the key features of smart water management. In the second definition I've given you, which is from the International Telecommunications Union, they also emphasize that it is one of its most important uses is to provide the basis for sustainable water management and consumption. Okay, so in terms of our case study that I just showed you, the Republic of Korea has championed smart water management for 10 years now. And they've, of course, Korea is one of the world's technology centers. and the Korea is a leader in integrating smart water management into its policies. They provided us with 3 case studies, but they had quite an assemblage of possibilities to provide us. And at least they're proud that they are pretty far along in applying smart water management. They have than most other countries. The report that we have, it's not yet online. Pretty soon it'll be online, and you can access it through both, I think, K-Water and the IWRA websites. Looks at 10 different case studies, each one of about 50 pages in length, so quite in depth, with background, the technologies, and the strengths and limitations, and 9 short cases of upcoming and potential smart water projects. The geographical distribution is pretty wide. The darker colors here are the 50-page case studies. The coverage, a lot of Africa, 1 case in China, and several in Korea, Europe, and Canada, Mexico, and then with filling in of the smaller cases. The specific projects, this is a list of the 10 cases. I won't go into a great deal of detail on this because I know we're already about 10 minutes behind on time. But 3 were from Korea, 1 of which was nationwide, the K-HIT Flood and Drought Integrated Network. There were 2 that are based on smart cities. In Korea, 1 is Paju, 1 is Seosan. 1 provides for quality monitoring for drinking water, Paju. Another one is focusing also on community satisfaction, end user satisfaction, but with more of a focus on revenue recovery through increased leak detection. The 1 from Paris, where I had the good fortune to spend 9 months last year, is an integrated network for improved real-time water quality in the sanitation sector. Paris has a physically integrated but an administratively decentralized sanitation sector. 1 from China that really deals with groundwater modeling in agriculture in the North China Plain, which is, of course, as probably everyone knows, is suffering from severe over withdrawal. The need to put some limits on that and to monitor it through the 3 red lines and other things has stimulated this kind of project to actually be able to track and to measure groundwater use. That one I won't deal with because I don't think it's so relevant for Hong Kong. 1 from Mexico is on a university campus to put smart sensors for drinking and wastewater quality and leak detection. Somewhat a small-scale experiment that is also aimed at making the students a little bit happier about drinking tap water and making sure that the tap water they drink is safe. We had 1 that is on flood and drought monitoring tools that was with IWA and the Global Environmental Facility, mostly African countries, that makes use of satellite communications for countries that have limited capacity to develop their own tools. Another one on agriculture, and that again I won't deal with very much, although it's fascinating use of small-scale technology. Smart water for Europe, which might have a lot of implications for Hong Kong, with demonstration sites addressing leak detection water quality, community satisfaction, and energy optimization. That one is a UNESCO-based project, and we're pleased to have a chapter from them. And one from Canada, which is an attempt to actually look at, introduce a smart grid for stormwater at the household level. Again, I won't mention that one, I won't go into that one in great depth here because it hasn't really been successful, but it's a good idea. The cases I think are perhaps of most interest to Hong Kong would be the smart cities in Korea, because those are cities, Seosan for leak detection and Paju for real-time public information on water quality, and in the Smart Water for Europe project. The integrated wastewater treatment and sewerage system in Greater Paris, I don't know if Hong Kong has a problem with the integrated wastewater treatment and sewerage, but it's just a very interesting model for a large system, large data system, as are the regional sensing and monitoring networks for flood and drought in the K-HIT. So Seosan, for those who like the Chinese characters, I've added them here, city has this is the sort of the visual depiction with the meters, transmitters, telecommunication, going through the internet, all about monitoring water leakage and communicating with the citizens at the end. They have produced a 20% improvement in the revenue to water ratio by detecting and addressing leakage with significant reduction in leakage. It has hourly monitoring and communications. The forcing factors for this was the national plans to address drought situations. Korea is a country that's quite prone to both droughts and floods. It has the lowest per capita water availability in all of East Asia, and the high level of non-revenue water. Now this does resonate with what I understand of Hong Kong as well. Enabling factors the state supported it heavily in terms of building the new infrastructure that was necessary, and there was a national policy that supports smart water management for improved efficiency. So the Korean government is willing to put resources behind new experimental sites. Paju, similarly, the focus there in Korea is famous in the world for its consumption of bottled water, because no one wants to drink the tap water. And that creates certain revenue problems for the utilities. If they can get better use of the tap water, more use of the tap water, they get more revenue and more confidence on the part of the citizenry in the quality of the delivery systems. So in 3 years, by using very sophisticated smart water and, of course, the engineering that accompanies it, they have been able to increase the consumption of tap water from virtually nothing to 36.3%. So that's quite a success rate. And they do that by, again, informing the end users, by finding technologies that are accessible to the consumers. The forcing factors there, as I mentioned, were the only 1% were drinking tap water, and selection by the state as a test site. The enabling factors, again, funding, support also presumably in terms of ensuring that the governance structure, the various rules that would apply, also accommodated this. And also they expect that in the end, right now it's not that it's an investment. They think that within 8 years or so they will actually be able to recover their costs. Smart Water for Europe is I made some extra notes on Smart Water for Europe here, but this is also an attempt to integrate smart water management in 4 countries using kind of test sites, with the focus being on water quality, leak detection, and energy optimization. I think this last one is kind of a very interesting thing, because often water optimization entails energy optimization as well. The key challenges you can see are down here is water quality management, especially biocontamination, leak detection, energy optimization, and customer interaction again. And one of its purposes was to create business cases for savings and improved resource efficiency. So whether or not the business sector is involved, they want to introduce a kind of a business approach to this. Forcing factors is there was a lack of integration in Europe in terms of the different factors, the water quality, leak detection, energy use for separate sectors. There's need to integrate those. The enabling factors was funding from the EU and extensive collaboration. So I think one of the important things for any of these kinds of things is that smart water requires collaboration across society and across various stakeholders. And another point here, I'll make a separate point, an additional point here on the Smart Water for Europe, because technology isn't the problem in Europe. I mean, Europe has lots of technology. The problems were lack of integrated and open solutions to meet industry standards, the lack of an ability to comply with what users wanted, the lack of good demonstration cases so water utilities would be willing to make the changes, lack of business intelligence awareness so as to challenge and change traditional water management approaches, and again, very important, in fact, I was talking to Bobby about this just now, political and regulatory support. If you don't have that, it's going to be very difficult to do anything. In Paris, they have worked, I think, for about 10 years or so on developing a real-time control system they call MAGIS for Greater Paris. It involves, Greater Paris has 6 wastewater treatment plants, and they are administratively separate with decentralization moves, but they are physically integrated so that one can move wastewater from one to the other. And there are a number of operator members and outside members, essentially government bodies. The focus is to meet the standards of the European Water Directive for wastewater quality. And in so doing, make Paris a lot more popular with its downstream neighbors, because Paris used to be notorious for its for the bad quality of its wastewater discharge, improving ecosystems and the like. In this case, the forcing factors were the framework directive. The enabling factors was that the water agencies, I think they used to be unified, then they were split up, but they strongly supported and collaboration. All of the relevant agencies were interested in working together on this, and they were backed by their CEOs. And they're more interested in this case. Unlike one of the previous cases, they weren't so interested in financial recovery. They don't even know if this system will pass any sort of benefit cost criterion, but they see it as an approach that is necessary, and they see that smart water, this kind of smart water approach, is something that will be, it's essential for the future, and it's something that needs to be continuously adapted, continuously updated. Back to Korea, the Korean Hydro Intelligent Toolkit, flood and drought control, that integrates like precipitation forecast systems, flood analysis, real-time hydrological data, reservoir systems, to get an integrated operation system. Korea's, as I mentioned, is very prone to both drought and flood, and in particular, I think, to flood. It's a monsoonal climate, and as I think in particular strongly monsoonal like North China, and it has short rivers, somewhat like Japan. That's makes for a rather difficult management problem, but if they don't save the water in the reservoirs, then they're likely to be hit by drought. So it's a tricky reservoir operation. It's also a little bit tricky because the reservoirs generate a lot of Korea's power. So this is one case that they needed to try to come up with some sort of integrated system. Forcing factors are the ones I mentioned. The enabling factor is that K-Water operates a significant, not everything, but a significant proportion of the dams. And they're in charge both of flood control and hydropower, so that they can add the drought control there. To sum up, it was very difficult. I mean, these cases are quite elaborate and quite varied, but we did try to do a summary of the enablers and the barriers and the benefits to adoption of smart water management from these case studies. Of course, there are many, many more around the world, but watch these. One, the enabler is to make the long-term investment. There has to be a willingness to commit. I mean, one of the drivers for smart water management is often that we've kind of hit the wall in terms of traditional old-fashioned infrastructure, but and being able to fund that. But still, long-term investment is required. Political support is essential. Two-pronged approach means it's not only technical, it is engineering plus policy plus involvement of the end users. Local stakeholder engagement and knowledge sharing is critical in many cases. Having the cross-sectoral, multidisciplinary approach, all of this sort of sounds like the new center. And integrating the smart tools with the traditional infrastructure. You don't create new infrastructure. The barriers, again, is getting that initial support and the investment. One problem, I've even heard it in some discussions today, is the technology often changes so rapidly. So you don't want to get locked into an old technology. The case in Mexico did that. They put in radio towers or something, and then all of a sudden radio towers were no longer used satellite communications. So they put a lot of investment, the funds that they had, into old technology. So it's a tricky question. Which one, how do you do this? In developing countries, you have problems with unstable electricity and internet connections. I don't think that's an issue here. A lack of standardization across the technologies. I think especially if you get the private sector involved, this can be a problem. It may be a problem in general. And the water utilities and governments, they like to do things the way they always have if they can. So locked into the traditional infrastructure, and it's a little hard. To the extent that smart water management involves more than just an add-on, that it involves actually changing the way things are done, then that can cause some reluctance. The benefits, I was really surprised to see the first one, because we always think of AI or any of these things as being a job killer. And certainly if you put in automated water reading, then your water readers are out of a job, for example. But it creates a lot of new IT jobs. And so on balance, it seems that smart water management creates more jobs than it displaces. based on our small sample. Increased trust by end users. Improved decision-making opportunities, capacity building, further education opportunities, and very importantly, I think, increased resilience on all fronts to climate change, to the impacts of climate change. Now here is the speculative part of my presentation. How long do I have to speculate? About 15 minutes? Okay. Implications for Hong Kong. I say, you know, this room in particular, you guys know more than I do, but I'd like to just sort of get the pot boiling, get the conversation going. Now, a typical description of Hong Kong's water management problems that you see, at least in the literature, is, people use too much water here. Per capita water use is too high. Look at Singapore. We'll look at Europe. And unlike there, actually, maybe it's going up a bit. Water charges are low. They haven't been raised since 1995-96. It's a whole different regime. And incomes have gone up, prices have gone up. Basically, might as well say water is free in Hong Kong. The delivery system leaks more than best practice. This is, I think there were some new reports that really showed this is even more significant than we thought, and it's getting worse in the private properties. And 80% of Hong Kong's water is from somewhere else, the Dongjiang. And then another one that I added, perhaps because I was interested in this, the lead scare of a couple of years ago. I wrote an op-ed for the South China Morning Post on it, and the public concern about the quality of the tap water, at least in terms of lead. Can smart water management fix these problems? I'm skeptical. But it's not because of the technology. I think that certainly, again, from what little I've learned this time, the WSD is making a lot of good efforts to apply smart water management in areas such as leak detection, including the district management areas, and using automated meters at the household level. I think that's good. But I'd say all of the cases that we cited had some sort of driving force. European water framework, need to reduce non-revenue water, water scarcity, frequent floods and droughts. And with few exceptions, it seems that it's hard for me to think of a driving force like that for Hong Kong to solve the problems. And perhaps because, in my mind, those aren't the real problems. The underlying problems are more institutional. Maybe I'm being deliberately provocative, and if so, then I'm inviting you to prove me wrong. But first big problem is Hong Kong is awash in water. Hong Kong buys more water than it can use. That 80% from the Dongjiang, it's a fixed amount. There's nothing, and if we look at this, I don't know if this has, you have to walk over here. Here's the only time that it was fully used. So, my training is an economist. I say, well, if essentially the marginal cost of water to Hong Kong is zero, not much of an incentive to do anything. Not only that, the costs are covered by the government. The government is willing to pay the rising costs without raising the tariffs. So end users don't feel the pain. They don't even feel the pain of the rising cost of buying Dongjiang water. And one reason the government is willing to pay is because its budget is growing faster than the subsidy to water. So if you see the dark line, that's annual expenditure on water supply. It looks like it's going up pretty high, but if you look at the light line, that's the percentage of total public expenditure that goes to water supply. It becomes increasingly a very small part, and so it's kind of follow the money. This is just simply not a significant budgetary item. Well, can technological innovation help nonetheless? And we do have 3 advisors to the center. The third one couldn't make it here. His name is David Sedlock from University of California, Berkeley. So I looked up a little bit of what he'd written, and there was an article that he wrote with others that said there's an innovation deficit in most urban water systems, not just Hong Kong. In fact, he knows more about the U.S., where innovation is development, application, diffusion, and utilization of new technologies like smart water management. And it's not easy to adopt these new technologies when they come along because technologies, institutions, and social systems are intertwined, and technologies change faster than institutions and social systems. Institutions and social systems, like the lack of accountability in Hong Kong that I just described, can limit the applicability of technological limitations. Okay, so still, is there hope? Well, let's say the smart water cases that we studied are limited for the most part. They usually focus on real time. They don't intrinsically take a long view. They're largely sectoral. Even there are a couple of cases, the Smart Water for Europe crosses sectors. And most are top-down and primarily serve agency needs or policy imperatives that, despite engaging the end user, don't engage very strongly. But there are promising areas for development, I think. Smart technology, especially integrated data and control systems, could be developed smart water grids to overcome sectoral limitations and to integrate areas that have been resistant to integration in the past. So data can help to drive institutional change that will help systems to become more resilient. And that could be across agencies, water supply and drainage, water and environment, water and energy. There have been some institutional reforms on the mainland China, where water quality competencies have been moved over to the environment. In Korea, the water and environment agencies have been combined under one umbrella. So there, at the institutional level, there is in many cases, at the policy level, there is a feeling that integration should happen. And I think that smart technology can help promote that integration. I'm not the expert here, though, so I'll listen to the experts and tell me whether I'm wrong. And across borders, and I've been saying it is, Hong Kong and Shenzhen are like, you know, the old lips and teeth. Their neighbors, their water systems are integrated. They use the same, they even use the same water, the same reservoirs, and yet they don't really work together very often. Now maybe the new technologies can help them do that without losing their feeling of autonomy. And there I think, like the Paris example is where maybe you could have shared information without the autonomy. Bottom-up technologies that engage end users, I think, is a really exciting thing that sometimes gets missed in most of our cases, one of the Africa cases not. And in private sector engagement and cooperation with research community and government agencies. So the cases that may have relevance to Hong Kong, this is almost repetitive here, but the Paris one, because it provides a common control system that can still allow for decentralized management with an integrated structure. The K-HIT, again, information and control network for flood control, drought prevention, and hydropower in multiple basins It's a large-scale network, integrated, that I think would help. These are large integrated control systems. The open question is, can they overcome institutional barriers like the ones I just mentioned? But I also think Hong Kong has considerable potential for smart water management. Maybe not the ones that are in these cases even, but there are potential areas to develop that take advantage of the dynamic, innovative capacity that Hong Kong has in its private sector and its university research community. And I just noticed last week the Hong Kong government has been promoting, wants to promote this kind of innovation and the like. So I think this is a good sign. And I think that's one thing, for example, we know that other countries, Korea and Japan and the mainland, are engaged in smart water management research, but they're all top-down, intrinsically. They don't have anything, I think, that really can kind of incite a good impetus from a dynamic entrepreneurial, independent entrepreneurial sector. And that, so one example that I can see in the literature is the thinking outside of the box of the top-down innovations to think is more bottom-up. So here's an example from Houston in developing stakeholder empowerment instruments. And it goes back to the lead in the water. The University of Houston has created a way of testing for lead in your own water using your smartphone. Now, it's not commercially applicable yet, but the technology is there. They've developed a lens, an elastometer lens that you can make with an inkjet printer. You don't even need the 3D printer, apparently. It converts a smartphone into a fluorescent microscope, and then you use some additional chemicals, and you get a lead chromate that can be detected at 5 parts per billion. Okay, so that for those that don't know, the World Health Organization standard that was commonly cited at least a couple years ago is 10 parts per billion. So that's pretty good. It's not perfect because actually the World Health Organization also says the real health standard is 0 parts per billion, but it's pretty impossible for us to actually reach that limit. I have said enough, and actually I've been warned that I've almost out of my time anyway, so now I would like to abandon this post and learn from the rest of you. Thank you very much.
Thank you very much, Professor Lee. I'm very thankful for this kind invitation to come to Hong Kong for this advisory role. It's a really interesting and also challenging tasks that we are working on, and we are just starting, so I think first impressions are really positive. Just a few words about where I'm coming from. I'm coming from Finland. It's a small country in terms of population in Northern Europe, only 5.5 million people, but it's relatively large in terms of territory. So it's a little bit you can compare with Canada or Sweden or Norway. My university is called Aalto University. It was established 8 years ago as a merger of Helsinki University of Technology, Engineering School, and Helsinki School of Business, and School of Arts and Design of Helsinki. So the outset was kind of the driving force behind was put together engineers, economists, and designers to create innovations. kind of a temporary name for this university at this project was Innovation University. And I'm not sure if we have really fulfilled the expectations on this regard, but we are trying our best. And one of the signs of innovations around our university, or environment and innovation ecosystem around our university, is that we are hosting now since several years very big innovation activity and fair, which we call the world's biggest startup event, called Slush. And it's been also exported to several places in Asia, including Japan and China, Shanghai and Beijing in particular, and also to Singapore. So this photo that I have on the slide is not ancient, is from 3 days ago from Kowloon. I just shaped it to look a little bit old. But I'm coming to the theme of shopping and also to consumer society later on this talk. So my first question to you: who is this gentleman? He is likely to be the world's most selling recording artist of all times. He has sold more records than Elvis Presley and the Beatles together, and 3 times as many as Michael Jackson. So who is this gentleman? Anybody know in the audience? Yeah. Bing Crosby. But I'm sure I would not have known him, because I'm listening to different type of music, and I'm obviously also, I wasn't born when he was popular. Anyway, I'm showing his photo here just to somehow draw attention to the long-term commitment that we have with the infrastructure development. This photo is from 1930s from the United States, and I'm just guessing that these gentlemen might be listening to the songs of Bing Crosby those days. So they did a very good job. We don't really know who they are. We don't really know their music anymore, or the things that they were listening to. But they might be listening. They might have listened to these songs, for instance, $1 Million Baby. I rephrase this to $1 Billion Baby because of inflation. And then Pennies from Heaven. They were expecting pennies from heaven because it was hard work, and they had to earn each penny or each cent. But I'm using these names of these songs a little bit in a kind of innovative way. They were creating really a $1 Billion Baby, which is still in use. Still in the United States, nowadays they are replacing this infrastructure that these gentlemen constructed something like 60 to 100 years ago. So what we are doing now with our infrastructure might be a little bit similar. Even the youngest students in this hall might be 100 years old when we need to replace our infrastructure, if we do it well. It's important work. It costs really billions of dollars, but it might be working a couple of generations. And we have this same timeline that I describe also in Europe. We are coming in many countries, such as the Scandinavian countries and Germany, we are coming to the same kind of phase in the infrastructure development that this many decades, even generations old infrastructure needs replacement. It needs money, but it needs to be done, because then we can go on with healthy and environmental friendly society still, again, several decades. We are talking about huge sums of money globally. Some estimations for whole investment of infrastructure in annual basis globally, $3.2 trillion each year by 2030 to meet the Sustainable Development Goals. Big sums of money. Roughly 10% of that would go to water infrastructure. It creates value to society, which is not always so easy to measure. I come to this later. Like education, research, public health, and these kind of issues are a little bit similar. I guess most countries which are doing this replacement these days, I guess Hong Kong is also in a little bit similar situation. There has to be political will, there has to be kind of mechanisms to finance all this activity. At the same time, there has to be the maintenance, investment, and strangely, if it works well, this is a kind of dilemma that my professor, when I was a student, he said it very wisely that if we can create systems that work very well, nobody notices them. And it's also difficult to put kind of pressure to the government to fund them. It might be different here because your government is funding very, very well, but it's not always in countries like the States or European countries where you have to struggle for getting this replacement money, and we are talking about kind of depth of infrastructure investment. And now I'm coming to the links to what Professor Nickum was saying before about new technologies. We have this interesting dilemma that although we are talking about very long-term investments and technologies, these new technologies might have a very kind of short lifetime. So what to do? We are in a little bit new situation. So, and this is one of the topics that we will be discussing in this advisory panel. But at the same time, if we are able to create solutions that are functional, that might be marketable elsewhere, it might create a very big economic opportunity, startup opportunity. So where is global urbanization taking place? There are three big areas in the world in this regard: China, South Asia, Sub-Saharan Africa. They are following a little bit different phases these days. China is moving very fast, still something like maybe 10 years, 20 years, but after that it might settle down a little bit. So the urbanization process will relax a little bit maybe after that. But in South Asia, it's a little bit different because it's expected to grow much longer. And the cities might be still growing very, very fast to several decades. So it might be even that solutions that we are able to create now might be somehow marketable to those areas which are growing very fast, still long time. Sub-Saharan Africa is still different. It will grow still at least to the end of this century if the predictions are more or less correct. When we are talking about this kind of large-scale development issues and the water as a part of it, we often refer to kind of interplay of the Earth system and socio-economic system. And interestingly, the socio-economic system is part of the Earth system. So if we disregard the Earth system, our socio-economic system might not be so sustainable over long run. And since we are talking about investments in infrastructure that might be kind of still existing 80 years, 60 years, 100 years, I think it's better to have a little bit long perspective also with the Earth system trends and socio-economic system trends. I'm taking three aspects: education and research, technology, sustainability, and resilience, part of it. So globally, we are witnessing a very fast and positive trend of social and economic progress. I have here some indicators over several decades, actually 2 centuries. We can see that in terms of education, literacy, health issues, poverty issues, trends look pretty good, don't they? It's not everywhere, but in many places of the world this seems to happen. And also in this part of the world, very much. But what is kind of interesting is that although we have these positive trends in issues such as education, so people know more than before, they are more educated, and economy grows very fast. I have this GDP picture here, left down. It is expected to grow still very fast, and if we all go shopping to the Nathan Street shopping malls, and our children will do it, and our grandchildren will do it, so what will happen with this planet? I think this is a big concern. We already are creating lots of problems even at the planetary scale, like climate change. I think this is a big concern to engineers. Some Earth system scientists talk even about the great acceleration. There are big changes that have taken place in the past decades, and many of these trends are continuing, and what to do with them. We also see many of these similar trends in this area, in southern China and Hong Kong administrative region. Very fast population growth, really fast economic development and human progress, but also challenges with the environment. And this is a slide that I keep showing to my students because my generation has failed to do this, but maybe the future generations will be able to do it. So despite of all this progress that we have in economy, human development, built environment, we should at some point cut the pollution and degradation of the environment, climate change, and these kind of things. The global community has hard time now with the climate change agreements. But anyway, I think that this is something that we should be really worried when we are talking about urban development these days. This is the kind of Kuznets curve you might know from the economics. So we are witnessing the education boom. It's really amazing to see how fast the global population is getting more and more educated. It's not only Asia, it's also Africa, it's Latin America, and all places. And this education boom has led to technology boom. We are talking about industrial revolutions. Third industrial revolution was already half a century ago with the rise of electronics, IT systems, automation, and these kind of things. And now, within the context of smart water, we are talking about cyber physical systems. There are lots of new opportunities that we are just trying to figure out what they could be in the water sector. But it might be but it might not be. We don't know it yet that, for instance, in 10 or even 5 years, there are lots of success stories. I'm following a little bit some other areas of engineering and technology. For instance, in the energy side, there's already lots of smart grid, smart demand supply kind of applications available. And even my house in Helsinki has a online metering system for electricity and smart kind of tariff system that works pretty well. It's been there already almost 10 years. But that hasn't come to the water sector. Maybe it will come, maybe something else will come. And another sector which is quite close in a way is the health sector. You see lots of interesting startups and smart applications in the health sector side. It might be that one of the big drivers is that the health sector has lots of industrial development, lots of private sector, and it has also clear market. There's lots of money around. So water sector is more kind of public sector, public utility driven, but might be different in that sense. But there might be similarities. There might be lessons to learn from other sectors. But this is a kind of, well, I'm following a little bit Professor Nickum's style, a little bit provocative slide that although we have seen these technological booms and education boom, economic growth, we haven't seen globally water sector boom. And this is kind of a worry to me, why we haven't seen it. Maybe it's not as attractive. People rather go to shopping malls than use their money for the infrastructure. They are worried about very low tariffs what we are paying for water supply, but they are not worried about brand items that they are consuming. My thesis is that it's not only about affordability to infrastructure, but it's very much about the public and citizen choice, also about political choices. So what is the government's role in all this business? There's an interesting economist, originally from Italy, called Mazzucato. She says that government does more than enforce justice and provide security. It builds infrastructure, educates the young, maintains the population's health, finances fundamental research, and has often promoted economic development directly. And Mazzucato is one of the kind of persons that those who are criticizing very extensive capitalism these days, that they refer often to her. But interestingly, her theses are pretty similar to what Adam Smith was saying already 250 years ago. So nothing new really, but maybe something has been forgotten in between. So maybe this kind of caring role of the government should be a little bit understood better than these days in many countries. It's not really the problem in some part of Europe where I'm coming from, but if you look at some countries, it might be a little bit kind of forgotten. I draw kind of a diagram for Mazzucato's thoughts, as I'm an engineer and I'm interested in flow charts. So she says that there are activities in the society that are kind of value creation activities, and then there are activities that are value extraction activities. And once we are so interested always in measuring gross domestic product, GDP, we kind of overemphasize the value extraction where really we can see the GDP. We don't see it so well in education, we don't see it in infrastructure development, we don't see it in health, investment in healthcare, although they are very crucial in creating the GDP, but they are not measured unless if we don't invest in value creation activities, we don't see this kind of boom of GDP that we see in many countries in Asia or in Europe. And we should not forget taking a fair part of this value extraction part to the value creation side. So, starting to wrap up this presentation, there are some paradigms that are being used extensively these days in the context of sustainability and urbanization. First of all, sustainability issue, the balance between ecological, social, and economic aspects. I think I want to emphasize this concept, although it's not always so visible in water sector documents. Resilience, ability to handle increasing and unexpected stresses. Circular economy, where water is one of the really key elements. Smart water, Professor Nickum was elaborating this very much. Ecological design, co-evolution of socio-ecological systems, urban renewal, and like in China they call this ecological civilization. I think these all are relevant and should be, in a way, part of our water sector thinking. I take some points of sustainable development and also on circular economy. So the United Nations system has defined 17 goals for the Agenda 2030, meaning the goals for sustainable development until 2030. And clean water and sanitation is one of them. But we can see that there are lots of other goals too that are relevant to water sector. For instance, sustainable cities and communities, the 11, no hunger, agriculture uses lots of water, good health. Water is very important for public health. There's life below water, climate action, life on land, so forth. They all are related to water. And I think we are somehow maybe too modest within the water sector if we cannot use this leverage of kind of how important water is for many other sectors. Maybe we could sell our case better if we really went boldly out of the box 6. Clean water and sanitation. I mean, we have to do the clean water and sanitation well, as we have done before as well, but also use these kind of links to many other sectors which are important. Circular economy, it has become a very, very hot topic in Europe, and I can tell one example from Finland. Finland used to have lots of polluting heavy industry in pulp and paper, so chemical process industry. We still have, but it's no longer polluting at all. It almost completely uses nowadays closed chemical cycles, pollutes very little, and it used to consume a lot of energy. So we used to have lots of energy consumption, but now these plants, biotechnology plants, are producing more energy than they are consuming. So they are producing, for instance, biodiesel. For instance, I have a diesel car and I'm using biodiesel with a very low carbon footprint. And I can also tell one example from my city, from Helsinki. We have now a new generation of wastewater treatment plants which are producing a lot of bioenergy. So they also are kind of power plants for biogas production with this circular economy idea. So they bring money to the city and also pollute less. So there's lots of opportunities, and water sector is in many ways very much involved. Here I collected some features of Hong Kong's water supply, but this is pretty similar to what Professor Nickum was saying, so I skipped this. But I show a slide which has lots of words. It has lots of bullet points. I'm not expecting you to read this all, but we just finished the new water strategy for Finland a couple of months ago, and it's available in the web. If you like, you can have a look on it. You can find it very easily. So, coming to the conclusions, we have this development interplay in the water sector development. We have the socio-economic system, we have the earth system, we have the boom in economy and finance, we have the boom in education and research, we have the boom in technology, but we have still lots of trouble and increasing trouble with sustainability and resilience, and also lots of pressure to the ecology and nature. So what do we need for long-term sustainable and resilient waters? Since I'm teaching professionally the students, I'm targeting this slide very much also to the students. We need students, experts, policymakers, politicians, citizens who can do this, and with this I refer to this Kuznets curve, who can cut the link between growth and environmental problems in a big way. It's definitely needed. For that we need people who can communicate this to the society, make advocacy to the society, to the public and to the policymakers. In our university we are very much also talking about this at the strategic level and trying to educate people to find solutions, and we talk about game changers, need for game changers. It may benefit from T-learning. With T-learning I mean kind of a style of learning where you are a strong expert in your own field, very groundbreaking expert, but you can connect your work to others and you can communicate it to the people who are from different disciplines and who are also, or who should be also able to communicate it to the public at certain level. And I very much see the same idea between the center that we are working on now. I think it's a kind of universal need these days to be interdisciplinary and be connected to the policies and to the practice, but not compromising the high scientific rigor. It needs commitment, solution orientation, and investment in value creation. and particularly in these aspects or paradigms that I showed in the slide that I copied as a small copy to the lower part of this slide, like sustainability, resilience, circular economy, smart water, ecological design. So don't remember those concepts. Conclusions. Water sector. We are dealing with a very long-term commitment, but we have now this interesting challenge that we have technologies that are coming and going. So it's hard to see which ones to pick. But we need work that exactly this kind of work that Professor Nickum was saying before and referring to before, and what is being done here at the Hong Kong U and many other universities in looking at these new technologies and investigating them together with practitioners. Water sector creates value to society and economy. We need sufficient political will. We need sufficient public awareness. It's everybody's concern, everybody's using water, and everybody's responsibility. And areas such as Hong Kong and many European countries, we are in a global leadership position in these technologies and particularly in their application to the practice. So we need some global insight too, and also the sense of global responsibility. So thank you very much.
First of all, I'd like to thank Hong Kong U and this center to organize this forum, which is very interesting because it brings about the connection between the water sector and the social sector to this forum. And my response to Professor Nickum, a few things. I fully agree with the observation of Professor Nickum on the challenges that Hong Kong government are facing, or Hong Kong is facing. First of all, the water charge is low, and make people doesn't have the incentive to save water. And again, one of his observation is the involvement of the politician or the institution is indeed very important, because how you determine water charges, because there is no datum for water charges. If you go to the IWA sector, you can see the water charges in states or in elsewhere in the world. They have a long spectrum, and Hong Kong is almost in the lowest 5%. So that is one of the observation, and the other is the leakage. The leakage here in Hong Kong is high, but we have take measures to control the leakage, but it's not good enough. And again, the government has to invest a lot on the technology on the leakage. One of it is the asset management. Asset management, replacement against maintenance. Whether you put money more on maintenance or put more money on replacement, but there must be a threshold or cut line between the two. And again, you have to invest in the technology of these two aspects before you can decide which decision you are going to make. And on the technology-wise, I know the network management on the leakage. There are a lot of technologies going on. And I understand the department is going to invest a computer system or a network system to monitor the leakages. And I understand Singapore, they also monitor the water quality in the network. So I think one point Professor Nickum is point out that people are skeptical on the quality of water because of the excessive lead system. But actually that is a different thing from the network. It's from the pumping system. So I understand the department is not only look into the excessive lead system, because there are other heavy metals that do exist naturally in water. And then that leads to control the water quality at source rather than at the pumping system. Although the pumping system you still have to control because the pipes and fittings can leach heavy metals. It depends on what kind of raw material you make these pipes and fittings. One thing I really want to say is the Dongjia water. We don't buy more than we use. We buy the right of water. We don't actually buy the actual quantity, as you say, the ceiling. We buy the right to obtain the ceiling. We only extract or take water for what we need. So that's one thing I want to clarify here. And on one question, in fact, maybe Professor Nickum can answer later, is how does the citizen help in the leakage monitoring? In the first two slides, you said they have an interaction between the citizens. I don't know how they can help, because you said they can report the leakage, something like that. So maybe you can elaborate that later. Another thing on the technology is on the customer interaction. I can see that if the technology or by installing smart meters, probably we can determine the water consumption of the citizens, and in turn you can determine how much water you're going to store in the tank, and in turn you save energy in pumping excessive water for that purpose, in line with the electricity tariff, because the tariff can vary from different dates of the time. So this is something, again, anywhere you can establish, even if it's in Hong Kong, we still haven't have this initiative to do that. With the presentation of Professor Wareham, is you talk about the leverage of different aspects. I've been thinking, since we have carbon footprint, why can't we have water footprint? So that people are aware their activities, how much water they are using. So the people will be aware of the use of water, although we know there's scarcity of water around the world. And on the conclusion, you talk about the students should be involved in the process. Although there are other experts and professors who are knowledgeable on water management, but the students do have a lot of involvement in a sense that if you want to save water, I think you have to educate them at a very low age. And we, in fact, have promote a conservation starts from home. So we have to go to the schools and do seminars to educate the students. Obviously, for university students, probably you don't educate this kind of safe water to them, but the students here they can be very creative and innovative to create solutions for water management. So here are a few points that I want to respond to the talks. Thank you.
Yeah, thank you very much, Mr. Bobbin. May I invite Professor Kaimin Shih to come up here? Professor Shih is a professor of civil engineering here at Hong Kong U. Yeah. Kaimin.
All right, good afternoon, ladies and gentlemen. It's really exciting to have this two talk this afternoon. I was particularly impressed by a lot of new points actually coming out from these two talks, and personally got educated very, very much. First of all, I'd like to just extract some of the points that I want to reflect from Professor Nickum's talk. The first one, I think what you probably feel most strongly is that he strongly mentioned that top-down in the water innovation, in the water infrastructure is very important. Professor Nickum, Jim, and me, we both graduated from San Francisco area. He got his PhD from Berkeley. It was Stanford. It's very unlikely for us to accept top-down. We're bottom-up person. However, I'm sorry, in this system, we really need top-down. You know, it's just a great fact that he presented to tell us in order to really move forward, in order to really have the new thing come into this field, the top-down system needs to be there. And that's the way out. So I think it's an important message. I hope the government really understand their important role in assisting this movement. Secondly, I particularly like his point and organizing the enablers, the barriers, and also the benefit. That was a wonderful, wonderful table. And it points out a lot of things that we really need to have a good thinking about that. And they clarify a lot of the interactions, a lot of relationship between all the consequences and factors. One thing that he mentioned very interesting to me is that we probably have too many new technology inventions. Because a new technology invention somehow in the water industry we're not able to catch up. Well, I personally feel that is definitely the fact. That's something we have to think about. But I mean, when people are expecting the water industry to move as fast as what the other technology fields are moving up, I mean, I start to think about, are we really paying one very important part, which is the reliability, basically is the reliability of the system. I think probably one joke you heard about many, many times, I just want to say that, you know, like car industry, You know, the workers in the car industry is all very frustrated because people laugh at them, say, hey, we start having a personal computer in 1980s and see how fast our computer industry has progressed until right now. And you guys, how long before you start to make car and you still have a diesel engine, gasoline engine, that's it. And then the car industry people, I feel very frustrated, and someone stand up and say, if you allow our car to break down multiple times a day, like you have your computer frozen multiple times a day, then we will be progressing as fast as you, or even faster than you, right? Water industry is an industry that requires great securities in terms of the supply system, in terms of it needs to be reliable. And that, we probably have a little bit of different views in terms of the technology selection that we're supposed to have it. Or probably issue has its own more comfortable technology level. But I'm saying that we do need to upgrade the level compared to the current situations. But that is the part actually we engineers have to think about. What is the one that's most suitable instead of what are those most trendy technology that we're looking at. So I think in terms of that part really allow me to learn a lot. Lastly is that I think somehow partially related to this technology issue is that in terms of a small water management system, the smart management system we're thinking about, have anyone ever asked what if the system becomes not so smart in one in one day, you know? What if the system goes wrong? Who should be responsible? Are the smart system always the right choice for all different kind of water problems that we're facing? Today, when you open the tap, you believe the water is clean. Anyone have any hesitation to drink the glass of water that just come out, you know, or a boil from the tap water, from the tap? No, you trust that. You trust engineers. But now let me tell you, engineers are no more there. These are all AI. And when things go wrong, I don't know, nobody responsible because there's no people. What will be that scenario that we have to look into? I am saying that we do have to make selections. I mean, in terms of some of the very good systems that were presented right there, monitoring groundwater table, monitoring different, or maybe leakage detection. I think a lot of this new technology, artificial intelligence, is also really good. But what about the real-time monitoring of water quality, for example? What about the prevention of fraud? Who will be responsible to provide a reliable warning system? Who will be responsible to provide the great water quality to safeguard our health all the time? Are we giving this to new technology? And when it breaks, if not frequently, then who to blame? You know, I think all of this is something that we're discussing today in terms of a smart water management system. That we have to really, as an engineer, I'm actually, giving a reflection myself, we really have to look at it seriously and work with the experts, if not also the social science parts and also the other fields, to really look at and develop a relatively more robust system. In terms of the talk by Professor Varis, he raised quite a number of very important and very philosophical questions to me. And I had a deep thinking about that. I feel that we really had missed a lot of, as an engineering development or even the government encouraging of the technology advancement, really missed a lot of points. And he pointed out. When I'm an engineering professor, right? So I'm teaching courses, particularly for like it is in the university, the University Common Core course. Sometimes our students will not be engineering students. So one of my favorite questions I ask them is that, do you know, in terms of a design criteria or design concept, do you know how long, what is the lifetime of infrastructure, or say civil engineering infrastructure, supposed to serve us? I like to ask students, particularly for those non-engineers. People like us or Bobby, director, we're engineers, we know the answer. But I find most of the students answer me like, like when you build a bridge, how long are you expecting it to last? Most students are giving me like, 100, 200, 300, because they see a lot of old building, old bridge. I found they are overconfident in civil engineers. Our infrastructure, like water system right here, is what Professor Varis pointed out, 60 years, 100 years. The infrastructure, they do age, and they need maintenance, they need investments. This part is somehow very, very difficult to attract attentions. With that, the second point that I like to say is that governments or any funding agents always like the new sustainable strategy. And when they become old, they don't care. Where's the sustainability? Or let's put a little bit near term. What about the existing facility that really need maintenance, that really need, say, leak detections? Everybody talk about a new fiber optics and barriers in the soil to detect the pipe. That's only applicable for new line pipe. What about the pipes that is already been there for some time and keep leaking a lot of our water resources? Nobody talk about that. Or no funding agents will be interested to fund the part. So that direction, I think, is wrong. And that direction was clearly pointed out by Professor Varis for us to see whether we really have to adjust the directions that in terms of our current development of so-called sustainable development. Last point I want to mention is about the investments for the value creation and value extraction. He made a very clear picture for all of us. The values creation is not necessarily equal to the value extraction. That helps recall every time when we have a new research project, and the first question that we'll be asking is how much value will be extracted from here? I would say no, we are creating value. But the value that you will be able to extract right after this project is not necessarily equal to the value that we created. We're so near sites. Whatever project that you want to be funded, you have to tell them, hey, you put $1, you can immediately get $2 back. That's not investment. That's not what our water industry can be. We need to have enough room, particularly for the university research institutes, to get government funding, again, top down, to have enough room for a lot of value creations. Director was one of the very good person knowing this and founding university a lot when he was in deputy directors. And I think that's exactly the case that we need, that's exactly the example that we want. The creation of the value needs to be continued, needs to be enlarged compared to certain scales. Another new technology, for example, Professor XYD has been also helping with the so-called the dye material, thinking for how can we prevent the cross-contamination when we're looking for the water reclamation in Hong Kong. So all of this technology needs a lot of investment upfront, a lot of investment that we should really create right now instead of just looking for the immediate extractions at the end. So again, I just want to say thank you so much. It was really, really fruitful for our thought, for our development in Hong Kong, and I wish this conversation can continue with the audience question later on. Thank you very much.
Yeah, thank you very much, Kaimin. May I now invite Professor Nickum, Professor Varis, and Kaimin, and Director could come up here so that we can start our panel discussion. One of the primary objectives of the Center for Water Technology Policy is to promote this dialogue between the engineers and the social scientists. Basically, this emphasis on the interfaculty or interdisciplinary collaboration is the key to tackling challenges new challenges associated with this increasing concern about climate change uncertainties and also this changing configuration of all the economies in the greater peripheral region. Yeah. Now, there's one model thinking about how the center can promote a collaboration to resolve or address all these new or emerging water policy sector challenges, and that is we need to somehow come with this imagination, right, in terms of policy solution by redefining those challenges, in the water sector. Yeah. So instead of waiting for the technology to develop, then we can make use of technology to address policy problem. Then we define the policy problem, we define the policy challenges, and then we challenge the engineers to come with the solution. So I think that's another way to think about how technology policy interface could contribute, to new solution, But that requires a kind of imagination, right? Redefining challenges that we are supposed to tackle. Yeah, and I think today we are listening to two presentations, one by Professor Nickum and another one by Professor Varis, and they sort of in a way they're challenging us to think, in a different way, so provocative manner, to think about how should we define the challenges that we are confronted with, at the urban scale. But the urban scale will have to be situated in a basin perspective. Hong Kong should be, the water policy problems in Hong Kong, meaning the urban water system problems in Hong Kong will have to be defined, from the perspective of a larger basin. And that is somehow lacking, in a way that we think about long-term water policy in Hong Kong in a very long time. Yeah. So that's all my introduction. So the backdrop. To this Q&A session. Now we're now open. If you have any questions regarding the presentations and also the feedback provided by the two discussants, you're now welcome to raise your questions. Yes, please.
My name is Phyllis Lee. I'm coming from the planning professional. I like the title of the center. It touches on policy and also technology. I think policy will lead the direction, and then technology will show the way to how to achieve that. But then, first of all, I think we must get our policy direction right first. It's very impressive to learn about urban water management, and I think especially sustainable urban water management is very important to the region, that is the Guangdong PRD area, as well as to Hong Kong. I wonder if we can approach this question from a wider perspective. We talk a lot about buying water from Dongjiang River, and then we are paying to what we have the right to do it. But in actual fact, water resources are very limited right now in the Pearl River Delta area because of the very rapid pace of urbanization. Even for Dongjiang itself, it has to have a trade-off because they are containing the urbanization to protect the water resources and then to give it to Hong Kong, Macau, and also Shenzhen as well. So they're talking about ecological compensation in that respect. That's why I think, first of all, we must approach this problem with a kind of more holistic approach that is transboundary and trans-region. Secondly, the land resource problem is also very pertinent to Hong Kong in the sense that we are still relying on a lot of these water reservoirs for the water reserve and also for the water consumption. But in actual fact, these water reservoirs are protected by a vast area of water catchment. In the context of Hong Kong, subject to very scarce land resources, this is actually a kind of opportunity forgone for the city as a whole. So I just want, I've heard about this sort of so-called total water management policy of government. We are buying up water from Dongjiang, but at the same time, we are also going to say to preserve the water reserve of the rainwater, as well as going forward for the desalinization of the seawater. Saying that we should be more resilient in terms of our water supply. But in actual fact, can we build a more, what should I say, a more optimal package of supply to optimize the use of scarce resources? Secondly, on the supply side, I have not heard about anybody talking here today talking about concepts say like sponge city. That is, we try to make use of the water resources until the very end before they are discharged back to the ocean or to the river. So I would like to maybe the speaker can highlight on this and how we can have a more integrated approach in terms of the utilization of the water resources. Thank you.
Anyone?
Let me try to answer part of the question. We in Hong Kong, we do have a strategy, what we call the total water management, and the strategy is as you, Professor Lee said, is quite simple. It's first of all we should contain the growth before we exhaust the new resources. So in terms of containing the growth, I think the lecturer did mention one aspect is leakage management. Mm-hmm. One of the water are being lost through leakages. And the other conservation, like the people's behavior on the usage of water, is another thing that you can contain the growth. And there are other initiatives or measures that you can do. I mean, that's a strategy. And in terms of the new resources, there are various initiatives like reclaimed water, rainwater harvesting, desalination. And desalination, I would say, could be the last resort because, yes, there are a lot of water in the sea. But again, on the other hand, you need a lot of energy to convert that to fresh water for drinking. And that could be the last resources. Mm-hmm. On the point of transboundary management, I think water resources in two aspects are in scarcity. One is quantity is in scale, and the other is the quality. Because once the water is contaminated, it cannot be used. Mm-hmm. So we are scared of, we lack of that amount of water being contaminated. So one of the water management that need to play effort is to control the water at source. Mm-hmm. So once either you collect or you have water gathering ground or even from whatever else, from rivers, they should be well protected. Otherwise, the resources will be lost. That's my point. Maybe the professors have others observations.
Yeah, if I may sort of cut in to sort of supplement what Bobby has just said. Yeah, the total water management strategy right now has been like 10 years. It was introduced in year 2008. For the past 3 years, the Department of the Water Supply Department has been formulating total water management strategy 2.0. Has not been released. I think it's still in the making. But if you looked at the original strategy, okay, the strategy introduced in the year 2008 is based on two premises. One, there's increasing competition for water between Hong Kong and also the jurisdictions relying on the East River for water supply. Okay, so basically, Koyuan, Dongguan, Huizhou, Shenzhen, and also the eastern part of Guangzhou. Yeah, so that is one premise: increasing competition for water. Second, is that you have climate change impact. So there are climate change uncertainties. So based on these two considerations, then the strategy emphasizes the importance of both water demand management and also supply, water demand management, also supply management methods. Okay. Look at the first premise. Then we here at the center, Water Center, Center for Water Technology and Policy, we're looking at data on water demand in the Prefecture region. And we found out that instead of like, if you look at the data for 2008, 2009, 2010, there was an increasing trend. But since the turn of, basically since about 2011, it actually is coming down. I mean, total demand for water in the Greater Prefecture region, okay, the 5 cities just mentioned, including Hong Kong, okay, is actually declining for two reasons. One, industrialization, and then second is urbanization. Okay, and what you have is that you have increasing, the number of people relying on the water in the East River is going up because more people are coming into this region, right? So rapid urbanization, urban population growth. At the same time, a lot of the farmland has been converted into urban land. So basically, there's a drop in demand for water from the agricultural sector. And agricultural sector is the major user of water, okay, particularly in Koyuan, in Huizhou, and also in Dongguan, okay. So this drop, okay, in demand by the agricultural sector actually has led to this decline in total demand for water. Second, industrialization. Industrialization in the sense of, one, basically what you have is that you have this transformation of the industrial structure from factories into service-oriented industries. So basically, instead of like factories, and a lot of factories have been relocated outside of like Guangzhou, outside of the Prefecture region, and then they're moving into service-oriented industry. So with these two factors, the demand for water has actually total demand. Okay, so look at actual numbers, I mean empirical data. You actually see a drop in total demand for water in the Greater Prefecture region since about like 4 or 5 years ago. Yeah. So the conventional wisdom, okay, is no longer supported by empirical data. So we need to examine, okay, the challenge that we have to deal with. Second, climate change impacts. Now, when we look at projection, and we have colleagues in civil engineering, Dr. Chen, Ji Chen, and he has been looking at climate change impact. And so like projecting into the next like 50 to 80 years in southern China, and using IPCC AL5 assessment report 5 data, I mean the latest available data. And basically the conclusion, and Hong Kong Observatory has conducted similar studies on this climate change impact on rainfall pattern in southern China. The conclusion is that we're going to have more rain in the next 50 years, not less rain. Okay, but that's climate change, right? I mean, some parts of the world will be drier, some parts of the world will be wetter. So we're going to have weather. Okay, we have more rain. Okay, so if you look at risk, okay, I mean, basically we need to have a reassessment of the vulnerabilities of Hong Kong, okay, in regard to climate change impact. And I think the risk is more like, is flood, okay, we're going to have more water, not less water. Yeah, it doesn't mean that we don't have like drought episodes, okay? But basically, overall speaking, I mean, the risk is more related to flood, okay, rather than drought. Yeah. So yeah, I think it's important for us to, given that we have this new data, okay, from research, that we need to conduct a reassessment of the vulnerabilities that Hong Kong's urban water supply system is exposed to, so that we can devise a more sort of like appropriate long-term water strategy for Hong Kong to achieve water security and also water sustainability goals. Maybe.
just one caution. Yes, the industrial and also economic structure has been changing, but at the same time, the PRD is a region whereby there will be very fast additional urbanization and also population increase. For example, given all this Bay Area initiative and also the further opening up of the PRD for economic development to serve the whole of China.
Yeah, basically,
Maybe this is just a word of caution.
yes, but we looked at data from other parts of the world. Take a look at global cities. This is what we refer to, what the economists refer to as maturing water economies. So the Greater Bay, including Hong Kong, is going through that process. So basically, the demand for water has been going up, but now it's sort of like started to decline, okay? And that phenomenon has been observed in other global cities. So the Greater Bay of the region is no exception. So we're going through the same process. Because when you think about water use, okay, there's a limit to how much water we're going to use on a daily basis. So the major water user are the farming sector and the factories. And in the case of the Greater Bay of the region, both are in decline. Yeah. Maybe you can add.
Yeah, I guess I think you're right that a basin-wide perspective would be ideal. And I was just at an IWA conference where we were talking about cities and their basins. In general, I think cities tend to be in the lower parts of basins, and they tend to be first movers. They draw water from the watersheds, and now the areas in the watersheds are often wanting to develop themselves. The problems are either competition over water, but in this area, that's almost like what I said about Hong Kong. It's about the whole Dongjiang region and Pearl River region. There's enough water. The problem actually may be flood control, in which case I do think your suggestion about sponge cities, these new settlements in China, I hope, are going to be sponge cities. That is what in Europe might be called nature-based solutions to flood control, flood problems. We have we're going to have a special issue coming up on land for floods, where in Europe, where you start to look at the different areas of the basin and say, well, how can we make use of existing facilities, even facilities that are privately owned or have other uses, but use them intelligently to mitigate flood risk. We can't just rely on reservoirs now. But in terms of the smart water management, I think the promise is that somehow there might be an ability to have common large-scale data systems that would allow a much more integrated kind of flood control that is beneficial to all parties in the basin. The problem with that is institutional. Upstream has very few incentives to cooperate with downstream. When first I went to China in 1974, I asked one of the leading hydrologists at that time, well, what's the water doctrine in China? And it says very simple: upstream doesn't suffer.
Yeah, do we have any other question? You know what, let me because we work on this water policy, in particular Hong Kong water policy, for quite a while, yeah. We have a lot of ideas here. So this is a good platform, yeah. So maybe I'll respond to your second question, okay? You asked the second question regarding to the long-term water policy here in Hong Kong, right? Yeah. What kind of principles? Let me paraphrase your question so I understand correctly. Yeah, thinking about the long-term water policy in Hong Kong, then how should we formulate policy so that is going to be sustainable, resilient, using those, as a criteria, right, to evaluate Hong Kong's long-term water policy. Yeah. Now, I'd like to make one point, and that is, I think we need to embrace a paradigm shift, okay, in how we think about Hong Kong's water policy. For many years, for a very long time, okay, Hong Kong's thinking about water policy is very Hong Kong-centric. And I think it's about time that we move away from this Hong Kong-centric thinking to adopt a national perspective and also a basin perspective to think about Hong Kong's water policy. Otherwise, we are not going to make any forward. We're going to make any steps, okay, forward, okay? Now, for a very simple reason, right? Right now, what we have is that based on what we have found out, okay, looking at empirical data, okay, we're supposed to have more water than we need. And in fact, that's the case in terms of quantity, also in terms of quality, okay? In terms of quantity, okay, in terms of more than we need, okay? We look at the projection of water demand, and we also looked at the water availability, okay, in the Greater Perimeter region, particularly in the East River, Dongjiang River Basin, okay? Basically, we are talking about there's no need, okay, for us to worry about water availability until, I would say, like 2030, maybe even 2035. We look at projected water demand figures for Hong Kong and also for the Greater Perimeter region. Yeah. Now, if we have more than water, if we have more than enough water for us to use, so what's the rationale for us to conduct a water conservation campaign? I mean, how will you convince, okay, the community that we need to conserve water? So, for several years, okay, actually for more than several years, okay, one strategy, okay, is to use what we call a monetary measure, meaning what? Somehow to reform the water tariff regime by raising water tariff, okay, so that basically what, using pricing, then people may conserve water because then they can save money, okay. Well, the problem is that Hong Kong's water tariff is pretty low, okay, to begin with. Right now, on average, households are paying $50 per month for their water bill, $50 per month per household, okay. So even if you're going to raise water tariff by 100%, $50, I mean, you go to Starbucks, right? A couple of lattes is like $40, okay, $40, $45, okay. So it's not going to have a lot of impact. So we have reached conclusion basically in terms of the price elasticity of demand is concerned, okay, pretty inelastic because water price is so low to begin with. So we've got to think about non-monetary measures to get the message across that water as a resource is very precious. But not only from a Hong Kong perspective, but from a basin perspective, from a national perspective. So in order for Hong Kong's water policy to take on some larger meaning, you will have to be somehow linked to some kind of national policy imperative, such as ecological civilization. And Professor Varis has pointed out in his presentation, okay, ecological civilization is a national policy imperative, is a national policy goal, okay? And Hong Kong make a contribution to this larger national objective of building ecological civilization, basically what, improving basin, ecosystem health, okay, within the river basin. Yeah. One way to do that is we can take a very bold move, okay, and say that 10 years from now, we're going to reduce the amount of water that we import from the East River by half. So right now, we imported 820 million cubic meter of water from the East River. We say that, okay, by 2028 or by 2030, we're going to reduce the imported water, okay, by half, down to 410 million cubic meter. Then we can think about options, technology, okay, that are available to help us to become basically a resilient urban water system, okay? What does it mean? It means that we're going to reuse recycled water. Now, Singapore is relying on new water, okay, 40%. Desal, 25%. Now, right now, the dissolved plant that we are building in Zhongguan-O, okay, is going to produce like 50 million cubic meter of water in the capacity, which is equal to 5% of projected demand by 2020, okay. It's actually a standby mode, okay, it's not going to go into operation by 2020, yeah. And then reclaimed water under the total water management strategy would account for 2% of our total demand, yeah. So imagine, right, you're going to reduce our imported water from Dongjiang by 50%, and it is technically feasible. Now, Los Angeles has also basically introduced a target, okay, last year. The mayor of Los Angeles has basically said that they're going to reduce the import of water outside of Los Angeles by 50% in about 10 years' time, okay. So technologically speaking, we should be able to achieve that kind of self-sufficiency and contributing to a national policy agenda, ecological civilization. At the same time, we can make use of technology, and we are at the center. Professor X.Y. Lee is looking into wastewater reuse, and the water supply department is also investing resources into reclaimed water. Okay, so basically moving along that line. So imagine, right? We can then not so much like comparison. I mean, not really copying the Singaporean model, but the Singaporean model basically tells us that, well, we can go in that direction, basically diversifying our water sources. So instead of relying on seawater, we use basically replacing seawater by fresh water for our flushing system. Then we can recycle the water. Now, right now, seawater is makes up 22% of total demand. Okay, so basically, 22% could be recycled water, reclaimed water, and then instead of like 5% of dissolved water, take it to 20%, 25. Okay, so instead of like a standby mode, okay, we make it a replacement, basically replacing, okay, imported water. Then there's a lot of what I think what I'm trying to be provocative, okay, meaning what if we can with this vision, right, that Hong Kong, and you need to think about Hong Kong's water policy from a larger perspective, a national perspective or basin perspective, then the possibilities open up. Because we're not so Hong Kong centric, and I think about how can we save like bargaining with Guangdong, okay, instead of like $7, it's like $6.50 per cubic meter. Forget those bargaining, okay. I mean, those are minor matters, okay. I think we need to sort of broaden our perspective, and then a lot more options would open up for us to consider. Yeah. So that's what I would like to put on the table, and we can discuss. Yeah. Mm. Yes, Anthony. Yeah.
Brad, I entirely agree with what you are saying. One thing you left out is Hong Kong people still use a lot more water than they should be. So if I think it was mentioned by one of the speakers, behavioral change is very important. And if Hong Kong people can conserve, can use less, 10%, 15% less, we already can do a lot.
Exactly. I mean, water conservation, I forgot to mention that, yeah. Water conservation is another possibility to save water, yeah. And I think it's not money. You just want to, right, it's behavioral change. Now, behavioral change requires information. Right now, we have no idea how we use water in the household. We do not have that kind of data, okay? Meaning, we know how much water is being used on a per capita basis, 130 liters per person per day, okay? But we have no idea how people use that 130 liters in a household, okay? Is it being used for like washing, for cooking, for bathing, okay? So we need that information so that we can target the water conservation campaign, okay? And we also need to provide some kind of information, some kind of feedback information to people in the household. And that's where smart water technology would play a very critical role. In terms of like, if you could imagine, right, it's an app, right? You can pull out your smartphone, and then you can actually see, wow, at the end of the day, okay, this is how much how much water you've been using on a daily basis, for what purposes, for cooking, for bathing, for cleaning, for washing, then you can adjust accordingly. So you can set a target. Right now, I have no idea. It's only, now since 2014, there's a Let's Save 10 Liter campaign, right? About 4 years ago, Let's Save 10 Liters campaign. You look at Singapore's model, not Singapore model, look at Singapore experience. They have been able to do it. Basically, they were able to bring down per capita freshwater consumption by 1 liter per year in the last 10 years. Basically, it's not a big deal. It's doable. Yeah, by just changing at the margin, okay, how we consume water. But we need some kind of like mechanism to communicate that information to the user. And this is what we at the center are proposing to work on, to come up with a smart water technology, basically both the hardware and the software, to help users understand the composition of water use in a household so that they can change the behavior accordingly. But they need that kind of feedback information, right, to see whether or not actually they are reducing their water use on a daily basis. Yeah.
I would still advocate an increase in the water rate. Because even though, yes, we did the study that showed that at a very low water rate, there's no price elasticity and so on, but especially if you're going to link it with the smart technology that shows you the water use, then you may actually get an elasticity of demand. I mean, if I see that, if I cut back a little bit here, then I can save enough for a meal every month or something, you know. Mm-hmm. So the greater information also may change the economic calculation. Another point I'd like to go to, I appreciate that Bobby Ng agreed with me on almost everything except whether the Dongjiang was a purchase of water or a purchase of a water right. Mm. But that raised my economic background there. That was my degree at Berkeley, is economics. And if Hong Kong is buying a water right, then a water right, that's tradable, isn't it? It should be. My colleague at the Academy of Sciences, Josh Alfung, says it should be. So if Hong Kong is buying a water right, shouldn't it be able to cooperate with other entities in the Pearl River Delta by selling them water when they need it?
Yes, yes. In fact, there are other cities do ask us to sell our rights to them, but obviously the control is not us; it's Guangdong.
Yep.
Yeah, they have the so-called distribution plan. They decided which city they should have so many and so many. Mm-hmm. So I mean, it's not up to me to say whether we can sell or not. Yes, I mean, technically yes.
Well,
in fact, as I said, Shenzhen did ask.
They did.
Yeah. Pumping back the water back to them.
All right,
even cheaper.
Yeah. Okay. Well, there's all you have to do is work around Guangdong, huh?
We have to bring this discussion to an end in about 3 minutes. So maybe you can entertain one question. If there one question from the audience, yeah. Yes, please. Yeah. Have a quick question. Yeah.
Institutional changes. For example, at the moment, the Hong Kong Water Supplies Department is the only utilities inside the government. All the other utilities are in the private sector. And that's why it's so difficult to raise the tariff. And the other thing is the position of the Water Services Department, Supply Department, because it is under the Development Bureau rather than environmental. So people are not thinking about, people are thinking about expenditure or building things rather than from environmental point of view. So maybe the panelists can give us enlighten with some more ideas on this.
Okay. Okay, let me give you like a 1 minute response here. You point your finger on one of the critical institutional constraint to sort of like closing the loop of the urban water cycle here in Hong Kong. Yeah. Now, reclaimed water has been experimented, okay, for several years actually in Sabuhui in Fanliang. Yeah. And the problem is that the scale, you wasn't able to scale up because of this fragmentation of responsibilities between the water supply department on the one hand and the drainage services department on the other hand. Yeah. So in addition to technology, okay, that is being developed by our colleagues in civil engineering, right, in terms of wastewater reuse, we somehow need to make the departments work together. The water supply department and the drainage service department work together for water reuse to be feasible at a larger scale, okay? And so we are talking about basically reorganizing the departments, reorganizing the agencies responsible for the urban, or managing the urban water cycle. So basically, it's a question of how do we complete this urban water cycle so that it will contribute to long-term, Hong Kong's long-term water resilience or water sustainability. Oh, okay. So I think there's one challenge, okay, that we have to tackle in order to sort of like strengthen our water resilience. Yeah. So I'd like to bring this to an end, and once again, I'd like to thank our speakers and also our two discussants for a very provocative, stimulative talk this afternoon. Thank you very much, and thank you very much for coming to this forum. Yeah.